In this video, I'll show you how this injection molding machine works, some key features, and some explanations about the construction details. The most important feature of the machine is the barrel, and you can see the cutaway of it here. And this is a plasticizer. You can probably see it on the website and wondering what it is. And now I will show you how it works. On a smaller or a hobby style machines, what happens is you have a tube and you have plastic barrels that are lumped together in this cavity, and they're being heated by a heater like this. Well, this is actually a bigger heater. But the problem with that is that on the outer peripheral you get your pellets that melt fairly well, and in the middle the plastic doesn't conduct heat consistently as an insulator, so the middle actually stays colder while your outer edge gets overheated. And that is how Medium Machinery combated that problem with the introduction of this plasticizer. It goes in like this, and you can see there is a gap. About 1/8 of an inch goes all the way around this core, between this core and this tube, and the plastic gets jammed inside this this gap, and it gets evenly melted outside by the heater and inside by the plasticizer that conducts the heat from the heater going downwards and then coming up. This plasticizer, or the core, contains all the plastic around it. So if you want to mechanically remove plastic without having to flush out the unit, all you'll do is press it out from the bottom and it'll come out from the top, trapping all the old plastic around it. Another key feature of this machine is the case-hardened plunger that's attached to this rail via this bushing. And it goes in from the top. You can see there's about a 2-inch gap between the bottom of the plunger and the top of the plasticizer. And the reason this gap exists is because it acts as a cooling zone. You would have a cooling fan with a deflector blowing air across the barrel to cool this part. And the reason that is done is because pellets actually stay solid on the upper portion of the barrel where the plunger travels back and forth, and then melt on the bottom where you have your plasticizer. So what happens is the bottom of the plunger never sees the molten plastic. It's pushing solid pellets that push the molten plastic. And the reason that is done is so you can have a tolerance about 15 thousandths of an inch in between your plunger and your barrel for the fumes and the air bubbles to come out from the molten mass of the plastic, so you get maximum consistency and the best finish in your molded product. The next part I'm going to introduce is this temperature controller. You can see it has this PID controller in the front that has 2 displays. On one of them, it displays the actual temperature of the barrel directly from a thermocouple. And a second setting is the temperature you set by hand. And you can see how close they are, so you know when to inject and when to stop and when to wait. And a unique feature about this controller, it has a solid state relay directly driven by this PID controller. So you get much faster switching and much more precise temperature control. And you have a circuit board up here where you have labels for each wire. So you don't even need a wiring diagram. You'll be able to wire it up right out of the box by yourself. Then another interesting feature of this machine is the alignment jig. And this is it. This gets mounted in the back of the machine, as you can probably see from the pictures, and you're wondering what it is and how to work it. You have this angle, and it provides a backstop for the mold. And this little wings on the side, they provide the left and the right stops for the mold. So, so this is the mold, and it'll go like this. As you can see, it stops the mold, and so it locks it in the exact position, so it can't go in either direction. And so the benefit of that is once you have your sprue lined up one time, you set this bracket, you can adjust it, and it moves on the screws back and forth. And this wings, they move front to back. You can also loosen them up and tighten them up. And once you got it all set, you just pop your mold back in and it goes in the same exact position for very fast operation and cycle time. Another feature of our machine is the metal trusses, well, actually the steel trusses that you can see here. You can see there's a standard channel and there is a standard plate welded to the channel, and there's also some gussets in the middle. And the frame is constructed out of these members. They're similar in design, but they're not quite the same. So this way the machine can be constructed very inexpensively and have very light weight. Because an cast iron equivalent of something like this would be about 5 times the weight and probably about 3 times the cost. Another benefit of a steel trusses versus cast iron frame is the safety. If you accidentally overload the machine or if something malfunctions, this member is just going to bend. And it's going to keep bending until you can see it or until it can't bend anymore. With a cast iron, it will simply crack and fail. So that's much safer with this design. Then you have your hydraulic ram. This ram is hydraulic, but is actually powered by air. And the way that works, you have an air motor right here that's directly connected to a hydraulic pump. So you connect this to an air compressor, and it operates this pump and it drives the hydraulic ram to make this plunger come out back and forth and inject your plastic. Now, it also has a manual option on the side you can see here. If you only need to inject a couple of pieces, or if your part requires very great precision, that you want to feel the plastic flowing in by hand, you can use the manual pump. This concludes the presentation. This machine is manufactured in the USA with highest quality components and parts. And if you have any questions or concerns, please email or call us. Have a good day.